Welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a circular CFST column for its thermal analysis. We will start by double-clicking on Steady State Thermal module. We will first go to Engineering Data and double-click. We will create material concrete M30 and give its property of isotropic thermal conductivity, which is in terms of watt per meter Kelvin, this 2.5. Another material is steel, for which I'll give the value of isotropic thermal conductivity in watt per meter Kelvin, which is 50. Now we go to project and update project. Next I'll go to geometry and right click, new design modular geometry, units millimeter, XY plane look at. We will first go to sketching and draw circle. We will give it dimension. This is the inner circle, so I'll give this as 480 mm. You can click on look at, then go to modeling, extrude, select the sketch 1, apply. The depth is say 2 meter, so 2000 mm. Operation add material and select generate. So this is the column. Now I'll click on look at again to see this view. I'll go to XY plane and create a new sketch. I'll go to sketch 2, sketching. I'll choose circle. From the center, I will draw the circle which has been drawn already of 480 mm. And then I will draw another circle. I'll give dimension to this as 500 mm. Now I'll go to modeling and I'll go to extrude. Sketch 2 is what I'm going to apply. Operation is add frozen because I want to have two different parts here. And the depth is 2000 mm and generate. So this outer one is the steel tube and the inner one is the concrete material. So I'll go to this solid. I will rename this as concrete. And this one I'll rename as steel tube or just tube. Now suppose if you want to have a little more modification to this. So on this face, I will create another sketch, look at, I'll go to sketching and I'll draw a rectangle. I will give dimensions to this and also this dimension. This was 500 mm, so let me give this horizontal dimension as 800 mm. L5 will be 400. L6, for that I need to give this dimension also, so I will give this also as 800 and this dimension as 400. So I'll give V8. Before that I'll give L6 as 400 and this one as 800. So now this is created. So I will go to modeling, extrude. I will select the sketch 3 and apply. The depth is say 20 mm and the direction will be reversed because if I give towards this side it will cover the column also. So I'll just change the direction to reversed and generate. So you can see here this has been created. Now when you go for operation, this can be given as add frozen such that this will look like a third part over here. The material will be still concrete itself, but you can give add frozen and create a separate entity altogether. So that is this one. So I will rename this as base. So this is how the CFST column looks like. So once this is done, I'll close this. I'll go to model and double click. I'll first go to geometry. This concrete I'm going to give the material as a concrete M30. The tube will be given the material steel. And this base also is of concrete. Next I'll go to mesh and generate. Now you can see here this mesh is quite fine. So it is possible that in my version it may not work. So I will just change this default size of mesh to 1 meter and generate once again. I'll now go to steady state thermal, right click and insert temperature at this top end. So I'll select face option. I'll select both of them, apply. I'll give the temperature as say 80 degrees Celsius. On this surface, I will right click and insert convection. I'll give the film coefficient as say 100 watt per meter square degree Celsius and an ambient temperature of 22 degrees Celsius. And at this end, I will insert temperature, which is again ambient. So you can give this as 25 degrees Celsius if you want. I'll now go to solution, right click, insert thermal temperature. I also want to insert the total heat flux and the directional heat flux. I want to see the heat flux along the Z axis. So I'll change this axis to Z. I'll go to solution now and solve. The first result is of temperature. You can see the variation of temperature over the body. The maximum value is at the top where we have given 80 and slowly you can see a variation of temperature. Then we will see the total heat flux. The highest value is 13606 watt per meter square and minimum is 5.82 into 10 raised to minus 11 watt per meter square. And this is the directional heat flux along the Z axis. You can also see the directional heat flux along the X and the Y axis. So let's select along the X axis. X and Y both will be same because it is a circle. So let's solve once again and see. So this is along the X axis on the body. And this is along the Z axis, which is the vertical axis. Now suppose if you don't want to see this mesh, what you can do is you can go to edges and select no wireframe. You can go to contour and select smooth contour such that the colors blend into each other. You can use the probe option to see the value of directional heat flux over this body. Now it is showing minus because it is going downwards. Also you can see the max and the min value at any time by clicking on max min. And if you don't want to see those options, you can again click on them. Now animation would also help you to understand the flow of heat. So you can just click on this and you can see the change of this temperature. If you click on temperature and you go for animation, you can see the change in temperature over this CFST column. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.